Assalamualaikum warahmatullahi wabarakatuh, and good day to my panel, Dr. Muhammad Fairuz bin Ramli and Dr. Khairul Imran bin Sainat. My name is Muhammad Afiq Isham bin Yusuf. Today, I will be presenting my proposal about the simulation study on airflow feed around the various car antennas. This is my outline of presentation. So let's start with the introduction part. Automobile industry has been one of the biggest contributor to air pollution. Consumers' concern on the rising price of oil has also increased. This has created a great demand of fuel-efficient vehicles. These problems can be solved by enhancing the aerodynamic performance of vehicles. Automobile aerodynamics is the method of improving performance of vehicles to pass through air with least effort and better handling on road. So what is aerodynamic? Aerodynamic is the performance of objects to move through the air. The rules of aerodynamics explain how an object moving through air and is affected by the motion of air. The aerodynamic efficiency of a car's shape is measured by its coefficient of drag CD and coefficient of lift CL. So let's see what are the drag coefficient and lift coefficient. The drag is the force acting on an automobile in the direction opposite of vehicle motion. The pressure due to air hitting at the front side of the car and the vacuum formed at the back side of the car are the main cause of drag force. For the lift coefficient, the upward force acting on the automobile by the air flowing under the vehicle is called lift force. This force is very dangerous and causes lifting of vehicle and misses road grip. Most passenger cars use various add-ons including car antennas. The aerodynamic force and moments can change so drastically that noticeable effects on the driving can be felt by the driver. The car antenna has minimum effect on aerodynamic drag, and it depends on the type of car antennas. So let's move on to the next part, that is literature review. These are the examples of studies that aim to analyze the factors that can be reduce the aerodynamic drag. The first factor is the influence of the exterior body of the vehicle. So these are three examples of study on the influence of the exterior body of the vehicle, such as the underbody, rotating wheels, and frontal area on the car. The second factor is the attachment of add-ons devices or accessories on the car body. The example of devices used on the car are antenna, taxi signs, as well as roof rack with and without leather. So let's move to the next slides. Furthermore, there are also studies regarding the flow analysis, which has the same purpose to reduce the drag coefficient. Next is the problem statement. Due to the high price of oil and the global warming issues, consumers are now started to shift to a more fuel-efficient vehicle. Improving the fuel efficiency means the less gas is required by vehicle to travel to a specific distance. This effort will not just solve the problems regarding the high oil price due to less consumption of oil, but it can also help to reduce global warming and provide a greener way to conserve the earth due to less pollution will be produced. Objectives of this study are to study the effect of using different types of antenna on the aerodynamic performance of car. Second is to validate and compare the result of drag coefficient between present study and car manufacturer database. Third is to analyze the pressure counter and velocity field around three types of antennas and determination of the critical length with optimum to drag coefficient results. And lastly, to determine the best type of antennas on airflow field during the vehicle running. Let's go through to the next slides. Scope of study. This study will focus on analyzing pressure and velocity of the specimen model, which is BMW 320i sedan car, when different types of antennas are used. The three different types of antenna that will be used are carbon fiber shark fin antenna, shock premium rubber antenna, and stainless steel universal antenna. At the end of the studies, the best model of the antenna will be determined. Analysis of results from previous studies. Yuan and Wang have made analysis about the CD versus height of spoiler in different cases. Then, Chu et al. Analyzed the drag coefficient variation according to the shape design of outside rear view mirror. Next, Choi and Chu, they analyzed the value of the velocity and pressure of three different shapes of shark fin antennas. My proposed project is the simulation study on airflow field around various car antennas. There are three types of antennas that I will be designing using CATIA V5. The software that will be used in the project is CATIA V5 and ANSYS software. Next, I will explain about the methodology of my project. The first step is the 3D modeling, where the antennas will be modeled using CATIA V5. Then, the 3D model will be imported to ANSYS Plan for simulation. After that, the models will be applied mesh conditions to carry out simulated flow analysis. After meshing process, the flow parameters such as the type of flow, turbulent model, and velocity of fluid is applied. The next step is define boundary conditions. The specimen model will be applied similar boundary condition with the same velocity of air flux that has been set as inlet conditions in order to observe the airflow that occurs at the time of the running vehicle. Then, it will be simulated to obtain the drag coefficient CD to compare with a validated value. These are some figure that show the simulation that have I carried out. 7. Uh, I will remodel and retest the car with 3 different antennas. The car model will be attached with universal car antenna using Autodesk Function Modeler. And other simulation is tested for another 2 types of the car antennas, that is shark fin and carbon fiber. Lastly, comparison analysis result with other 3 different car antennas. I will run simulation for the 3 different antennas that have been attached with car models. Then it will mutually compare the resultant values of the flow analysis on each of the antenna models. When the 3 models are mutually compared, the value of maximum velocity and pressure could be determined. Lastly, the expected result. The best antenna model would be the shark fin antenna. The reason for this is that the antenna has a small size and its shape makes it occupies less space. So the airflow around it will be smaller as compared to universal and carbon fiber antennas which have a long shape. This will cause a reduction of drag coefficient. Thus, shark antenna is more aerodynamic efficient. So I attach some video of my simulation using the ANSYS Fluent. That's all for me. Thank you.